Hello, sixth graders. In section 10.3, we're going to talk about the quotient of powers property. The quotient of powers property is the powers property that's based on dividing. So let's write this down. We're going to come up with the property ourselves. 2 to the 8th power divided by 2 to the 6th. Now, as students, some of you may look at that and say, well, I'm going to figure out that 2 to the 8th power, whatever that is, I'm going to do that, find that as the top number. Then I'm going to take 2 to the 6th power, find that number, and then I'm going to divide them. Well, let's look. If we actually multiplied 2 to the 8th power, you're going to get 256. If we take 2 to the 6th power, 2 to the 6th power gives us 64. If we divide 256 divided by 64, you're going to get an answer of 4. Now you're probably thinking, well, that's easy, I can do that, which you should find easy. But we can use this as a shortcut. 2 to the 8th power is 2 times itself 8 times. And I do want you to write this down. Divided by 2 to the 6th power, which is 2 times itself 6 times. By rules of dividing, you should know that any number divided by itself is 1. So actually, 2 divided by 2, oh, that just gives me 1. It gives me 1. It cancels, 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 cancels. What are you left with? You're left with 2 times 2, which is 2 to the 2nd power, which then gives you 4. What rule could you make to go from this to this? You're going to subtract the powers when you're dividing by the same base. So your key idea says this. To divide powers with the same base, you're going to subtract their exponents. So you're going to take, for example, in numbers, 4 to the 5th divided by 4 to the 2nd. You have the same base of 4. We subtract the powers, and that will give us 4 to the power of 3. In algebraic terms, it would be a to the m power divided by a to the n, and that would give me a to the m minus n power. So let's do some examples. Now for each of these, I want you to simplify. Let's start with 3 to the 5th power divided by 3 to the 3rd. Well, 3 to the 5th power divided by 3 to the 3rd would give us 3 squared, which gives us 9, which I'm going to write underneath. B, negative 7 to the 9th divided by negative 7 to the 3rd. We have the same base. So we're going to subtract the powers, and what will we get? Negative 7 to the 6th power. Once again, those parentheses must be there. Now, if you took negative 7 to the 6th power, well, 7 times itself 6 times gives me 117,649. Now, is it negative? No. The reason is because I have an even power. Therefore, it's going to be a positive number. C, h to the 7th divided by h to the 6th. Well, that will give me just h to the 1st power, but we're only going to write that as just h. We never write the 1 power. We just leave it as an h. So example number 2, 3 to the 4th power times 3 squared divided by 3 to the 3rd. Step 1, we're going to do the numerator. 3 to the 4th times 3 to the 2nd would give me 3 to the 6th divided by 3 to the 3rd, so I subtract them. That gives me 3 to the 3rd power, and 3 to the 3rd power gives me 27. Example B, a to the 10th times, nope, let's change that. Let's do a to the 10th divided by a to the 6th times a to the 7th times a to the 4th. Well, we could do this two separate ways, but I'm going to divide first. A to the 10th divided by a to the 6th will give me a to the 4th. A to the 7th divided by a to the 4th is a to the 3rd. And my final answer would then give me a to the 7th power. Example number 3. Here's a real-life application. The projected population of Tennessee in the year 2030 is about 5 times 5.9 to the 8th power. Predict the average number of people per square mile in 2030 if there is about 5.9 to the 6th people per square mile in Tennessee. So we know that in 2030 there's going to be about 5 times 5.9 to the 8th power amount of people. Predict the average if per square mile there's approximately 5.9 to the 6th power. Well, we have to divide. So we're going to take 5 times 5.9 to the 8th power divided by 5.9 to the 6th. What do you think you're going to do first? And I want you to actually talk to the computer screen and tell me, what do you think you're going to do first here? If you said multiply, you're wrong. Here's why. This is multiplication. What's the base here? It's 5. What's the base here? It's 5.9. Therefore, you cannot combine these. They are not the same base. So what you have to do is you're going to divide first. So it's going to look something like this. 5 times 5.9 to the 8th divided by 5.9 to the 6th. Well, 5.9 to the 8th divided by 5.9 to the 6th gives me 5.9 to the 2nd power because you subtract the powers. If you evaluated that, 5 times 5.9 squared gives you approximately or about 174 people per square mile in Tennessee in 2030. In example 4, we're going to start putting all 3 days worth of stuff together. We're going to combine all of your problems together. Example A, 7 to the 5th power times negative 2 to the 8th divided by the product of 7 to the 4th and negative 2 to the 5th. Step 1, you don't have the same bases on top or on bottom, but you can do this. 7 to the 5th divided by 7 to the 4th. You can subtract them. That gives you 7 to the 1st, which is just 7, times negative 2. We have the same base again, negative 2 and negative 2. 8 minus 5 is 3. So negative 2 to the 3rd power gives us negative 8, and negative 8 times 7 gives us negative 56. And that's your answer. Now, before we go on, I know in your mind you're all thinking something, or some of you are. You're wondering, Mr. Humphreys, why is the bigger power always on top? What would happen if I had this? 7 to the 3rd over 7 to the 5th. Would that still be 7 to the 2nd? No. We still take 3 minus 5, that gives you 7 to the negative 2, which, by the way, you cannot have negative powers, which we'll get into tomorrow. So keep in mind that we will get there. Something you're going to also learn me say a lot more, which I'm not doing in this section, but I'll do it right now again. I may say, rather than to subtract the powers, I may ask you, where are there more 7s? On top. How many more 7s are on top than on bottom? 7. So you're going to have 7 on top. How many more negative 2s do you have on top than the bottom? 3. And you're going to notice when we get to negative exponents, that may help you a little bit. But I'm going to forewarn you, I may change it up a little bit next section. You're still going to subtract, but I may word it a little differently. So part B, let's make this one fun. Here we go, this one looks fun. 8x to the 3rd, all to the 2nd, times 1/2 x to the 4th y, all to the 3rd, and then all of that divided by 2x squared y, all to the second power. We're combining all of your rules that you've learned up until today. Let's take this one step at a time. It's not difficult, it's just, it looks confusing. So the first thing on top, we're going to take 8x to the third squared, and we're going to take this to the third power. We're going to get rid of our powers first. So 8x to the third squared, what is that? 8x to the third squared. Well, 8 squared is 64. X to the third to the second is x to the sixth, the powers to powers. Then we take 1/2 to the third power, which gives us 1/8. X to the 12th, y to the third. On the bottom, I'm going to take 2x squared y to the second power. That gives me 4x to the fourth, y squared. All right, now I'm going to multiply the top. 64 times 1/8. Well, 1/8 of 64 is just 8. X to the sixth times x to the 12th. That's going to give me x to the 18th, since we add powers with the same base. And then y to the third comes down. Over 4x to the fourth, y squared. And that's going to give me 8 divided by 4, which is 2. X to the 18th divided by x to the fourth, we subtract the powers and get x to the 14th. Y to the third divided by y to the second gives me y. So that entire problem simplifies down into 2x to the 14th y.